Our solar system is an amazing place. It's filled with planets, moons, asteroids, and comets, all dancing around a star we call the Sun. Imagine a giant swirling cloud of gas and dust. That's how our solar system started billions of years ago. It's hard to believe that something so grand began from something so small. Let's hop aboard our spaceship of imagination and travel back in time to witness the birth of our solar system. Fasten your seatbelts. It's going to be a cosmic adventure. Picture a huge cloud of gas and dust, much bigger than our entire solar system is today. This enormous cloud, known as a molecular cloud, was the birthplace of our solar system. This is called a molecular cloud. It was a chaotic place with particles moving around and bumping into each other. Imagine countless particles, each the size of a grain of sand, colliding and interacting in a vast cosmic dance. Gravity, the force that holds us to the Earth, started to pull everything in the cloud together. This gravitational pull caused the cloud to slowly collapse in on itself, drawing particles closer and closer. As the cloud collapsed, it started to spin faster and faster, just like a spinning top. This increase in speed was due to the conservation of angular momentum, a fundamental principle of physics. This spinning motion caused the cloud to flatten into a giant disk. Over time, this disk became more defined and structured, setting the stage for the formation of our solar system. Think of it like making a pizza crust. As you spin the dough, it flattens out. This analogy helps us understand how the spinning motion of the cloud led to the creation of a flat, disc-like structure. This disk is where our sun and all the planets were born. Within this protoplanetary disk, regions of higher density began to form, eventually leading to the creation of the sun, planets, moons, and other celestial bodies that make up our solar system today. At the center of this spinning disk, the sun was born. Gravity pulled so much material into the center that it became incredibly hot and dense. Eventually, the pressure and heat were so intense that nuclear fusion began. The sun started to shine. Meanwhile, in the rest of the disk, dust and gas started to clump together. These clumps grew bigger and bigger over time, forming planets, moons, and other objects. Imagine tiny snowballs rolling around in the snow, picking up more snow as they go. That's kind of how planets formed. Section 4, a family portrait, our solar system today. Fast forward billions of years, and here we are. Our solar system has evolved into a magnificent and complex system of celestial bodies, each with its own unique characteristics and mysteries. Our solar system is home to 8 incredible planets, each orbiting our central star, the Sun. These planets vary greatly in size, composition, and atmosphere. There's scorching hot Mercury, closest to the Sun. Its surface is covered with craters and it has no atmosphere to speak of, making it a harsh and barren world. Then there's Venus, shrouded in thick clouds of sulfuric acid. Its surface is hot enough to melt lead, and it rotates in the opposite direction to most other planets. Our home, Earth, is a beautiful blue and green oasis teeming with life. It has the perfect conditions for life as we know it, with water, an atmosphere, and a moderate climate. Next is Mars, the red planet, where scientists believe life might have once existed. Its surface is covered with iron oxide, giving it its distinctive color, and it has the largest volcano and canyon in the solar system. Further out, we have the gas giants. Jupiter, the biggest planet in our solar system, with its giant red spot, a massive storm that has been raging for centuries. Saturn, known for its beautiful rings. These rings are made up of ice and rock particles, and they are the most extensive ring system of any planet in our solar system. Uranus, tilted on its side. This unique tilt causes extreme seasonal variations, and it has faint rings and a cold, icy atmosphere. And Neptune, a blue giant with supersonic winds. Its deep blue color is due to the presence of methane in its atmosphere, and it has the strongest winds in the solar system. These planets are all fascinating and unique in their own way. Each one offers a glimpse into the diverse and dynamic nature of our solar system. A true family portrait of celestial wonders. Section 5. The sun's farewell and a new beginning, but even stars don't live forever. They are born, they live, and eventually they die. This is the inevitable cycle of the cosmos, a dance of creation and destruction that has been going on for billions of years. Billions of years from now, our sun will reach the end of its life. It has been shining for about 4.6 billion years and has enough fuel to last for another 5 billion years or so. it will expand into a red giant star, becoming so big that it might even swallow up the inner planets, including Earth. This transformation will be both magnificent and terrifying, a true testament to the power of stellar evolution. That's a long time from now, so no need to worry. Humanity has plenty of time to explore the cosmos and perhaps even find new homes among the stars. Eventually the sun will shed its outer layers, leaving behind a glowing white dwarf star. This remnant will slowly cool and fade over billions of years, a quiet end to a once mighty star. The material it sheds will drift out into space, perhaps one day becoming part of new stars and planets in a distant corner of the galaxy. This cosmic recycling is how the universe renews itself, so even in its death, the sun will contribute to the birth of new cosmic wonders. The cycle of life and death in the universe ensures that the cosmos is always evolving, always changing, and always full of new possibilities.